Bonjour et bon après-midi, good afternoon. We will do this in English this afternoon. So welcome to the Cloud Native Meetup Romandie for this afternoon, June 17th. I will start to share my screen as well to share with you what we are going to see this afternoon. So now that you can see everything, so I hope to welcome you and to be able as well to share with you so how it is organized. So we are with the speakers, Mohamed and Robin in English. We are in a Zoom conference call, and then we are streaming live on YouTube. So there is a little delay of 30 seconds, and we will be monitoring, of course, the chat and answer all your questions to make it as interactive as possible. So please don't hesitate to connect with us to ask us your questions. I invite you also to join us as well with Slido, and you can download the application or just take a quick snap with your cell phone and tell us where you're coming from, and then we'll be able to see where people are coming from a little bit and joining us today. So we can see we have from Annecy from France, Vevey, Genève, Échallens, Lausanne. So thank you very much for everybody to join us this afternoon. Hopefully, the more the merrier, and the more interesting the questions and the talks will be. Now, to introduce this afternoon's speaker and agenda. So I'm doing the introduction, and I will be the host of this evening. Then I will be joined with Robin Wyss from Dynatrace, who will speak about Keptn and how to automate sly and slow-based build validation. Then we'll take a 5-minute break and for you to rest and have a quick water, and then we'll join with Mohamed. Then we will talk about cloud native patterns and anti-patterns. So please make it this afternoon as interesting as possible, exchanging. We are here for this, and the more questions, the merrier. Thank you very much. And so now, I'll introduce to you Robin. Robin, so the floor is yours.
Perfect, thank you. I'll just start sharing my screen. Hopefully you can see my screen now. So thank you for having me, and welcome everyone to my presentation. So my name is Robin Wyss. I'm from Dynatrace, and today I'm going to talk about an open source project called Keptn. And so, and especially how are we going to use Keptn to automate SLI and SLO-based build validation. So yeah, just to give a quick introduction, I guess most of you are familiar with how build pipelines work. There's different tools on the market that are available. I mean, Jenkins, of course, is very popular, or Azure Pipelines, GitLab. I mean, there's plenty of it. Basically, what you do, you build a pipeline where you build your projects. You then deploy your projects to the test environment, run some tests, and then you need to decide, is this build good enough? Should we go ahead and promote it to staging and then to production? Or is this something that we need to adjust? And this step usually kind of breaks the pipeline a little bit. There's a lot of manual evaluation involved. Looking at the tests that you would typically do, you might do functional tests, which probably is the easier one to have a green, red, is it good or is it not good enough to deploy? But then it becomes a little bit more tricky when it comes to performance tests, right? So which performance is good enough? How much response time do you expect? How many errors are kind of acceptable? And typically this is done manually, and then there's a manual approval process involved where somebody decides, okay, this build is good enough, let's push it forward, or no, this build it needs to go back to development and we need to do improvements. And then also we need to figure out, where do we get the right data, right? It's not enough to just run the performance tests, but of course we need to have the results, make sure we have the right results for the tests we run, and also make sure that it's not kind of polluted by other data that we might have in our environment. So one goal will be to automate this, right? Because everybody likes automation. It makes things easier. You can go off and do something different. But of course, whatever you do, it's up to you. But what I think also this picture shows quite nicely, it's often challenging to do automation, right? You build something, you automate it, you're happy, and then something changed in the environment and it breaks. So this is kind of a challenge that we see. So automating is good, but it's not always easy to do. And so maybe just to take a step back and explain to you why Keptn, where does it come from? Why was it developed? What's its goal? So if you look at there was a survey from it's called the State of DevOps report. I think it was run by Puppet. And we see a lot of success in adoption of build pipelines, right? A lot of companies do build pipelines. There's private or public cloud infrastructures that's being used, which works well. And there's also good integrations to development environments. And monitoring, alerting is an important aspect as well, that you are able to include that into your pipelines as well with logging. But if you look at the challenges, what we see often and what I guess the report shows us is the main challenges are lack of time because it's time consuming, the lack of standardization. If you think about build pipelines, I mean, there's different tools, but how to combine them, everybody does it on their own way, and lack of technical skills because it takes time and it takes skills to build up a pipeline and to maintain it as well. And this is exactly what Keptn is aimed for. So the idea is to kind of take that burden of you, or at least alleviate that burden a little bit. So simplify the interaction between the tools in a standard way, and then don't have to use that much technical skills to that are necessary to maintain the pipeline. And here, just to show you an example, this is actually one of our internal build pipelines. It's more than 250 lines of code. And yeah, you could say we started breaking up the monolith to go to a microservice architecture when we come to software development. And it's kind of the build pipeline are becoming the new monolithic counterparts to that. Because it grows over time, it contains a mix of different information. You have information about the environments in which you deploy. You have information about the platforms that you use. So as soon as you maybe exchange a platform, it becomes tricky. And of course, you also need to target it to different tools, and that makes it quite challenging to build and maintain. And there's also no clear separation of concerns. So there's different people involved. There's the development involved. There is the DevOps engineers, of course, and site reliability engineers, but they all kind of work on that same pipeline. But then you could say, well, maybe it's not that bad, right? 250 lines of code, it's maintainable, even if there's a mixed bag of information inside. But the real challenge arises when you start. I spoke before about breaking up the monolith into microservices. That means for every service now you will have a build pipeline potentially. So then you have a new service or a new project, and then you need another pipeline. And what you do typically is you would copy the one you already created. You don't start from scratch, and you adjust it a little bit. And then for the next one as well, and the next one as well. And you improve it, but it doesn't go back to the original pipeline. So it becomes kind of branching out, and you have different versions of the pipeline, and you start copying things back and forth between different pipelines. And then, of course, this in very large environments, in very large teams, can become quite complex. So what is Keptn, right? This is the question that I want to answer tonight. So Keptn, in a nutshell, this is the official description that you would find on the website. So it's an event-based control plane for continuous delivery and automated operations for cloud-native applications. Which is a lot of buzzwords in one sentence, but the aim of Keptn is really not to replace existing tools, but to build a control plane to connect different tools and services to build your build pipeline. And an important aspect also is that it's event-based and configuration-driven. And of course, it's also made for a kind of cloud-native approach. It runs itself on Kubernetes, and it's actually a cloud-native sandbox project. And I think just a couple of days back, they raised a pull request to get it in the next stage of the. Now I forgot the name of the different stages, but if you want to support Keptn, you can go to the GitHub and help it push to the next stage out of the sandbox stage. So to give you a quick overview of how it looks like, so there's different kind of use cases that are covered by Keptn. So we start by picking a use case. Today, we're going to look at SLO-based quality gates, but that can be also part of a progressive delivery. So meaning that you have an automated delivery that goes into an environment, runs tests, and then once the tests are successful, it goes to the next stage and so forth. And then we have more advanced also use cases. So for example, auto remediation is one step that you can use it for. So if a problem is detected, you can launch some auto remediation steps and also in S3 automation, setting up environments automatically. So that could be different use cases that can be that Keptn can be used for. And then once you have your use case, you need to define a configuration. As I mentioned before, it's configuration based. There are different types of files, and we'll see those in more details. But there's a shipyard file that defines your environment. Then for the SLI SLO approach, we have a file where we define the SLIs and SLOs. And then different other files like workload and runbook, and basically to connect the different solutions through Keptn. So really that's the goal. So not replace whatever you have, but really connect the tools that you already use. For example, if it's Helm for deploying into Kubernetes, if you use, for example, Argo CD, no matter your monitoring environment, if it's Prometheus, use Dynatrace, for example, and then JMeter, for example, to run the tests. And as you can see, so this is a screenshot of, there's a UI coming with Keptn. It's called the Keptn's Bridge, and where you can see how the different stages look like. So you can see your configuration, how it results into the different stages. When you run the tests, you would get some build feedback that shows you if it passes, if it doesn't pass. So the typical things you would expect from a tool that handles your build pipeline. And all of that happened through an event-driven approach. So it's all event-based, and it basically orchestrates the connection of the tools. It also uses a GitOps approach, so meaning that your configurations would be maintained in Git, so you have traceability. And as I mentioned before, it's a declarative approach, so you write YAML files and you don't write code to build the pipeline. So now let's have a look at how we would go about creating an SLO-driven multi-stage delivery. So what we want to achieve is to have a pipeline where we deploy to a development environment. Then we run some functional tests, evaluate the tests. If they are successful, we move to the next stage. And the next stage would be staging, where we deploy, where we use basically a blue-green deployment. So first there's a staging canary where we run the performance tests, do an evaluation based on the result of the performance tests. And then if they are successful, deploy to staging, and from there move to production again with blue-green deployment. So we have a production canary and then a production deployment. And to get started, so first thing you typically do in Keptn is define a shipyard file. So the shipyard, and I guess you got by now that we use some nautical terms in Keptn, right? So Keptn, like captain, and then the shipyard. We also have a lighthouse service. This is kind of the terminology used within Keptn. And then we have an SLO YAML where we define the SLO kind of the service level objectives that we want to achieve. And we use Helm charts in this example to deploy the service. But this could be any other tool, for example, you could do trigger the deployments to Jenkins or anything else, and that will result in your pipeline. And then, as we see in Keptn, this is how it looks like. So we have the different stages, and I'll show that in the UI in a second. So first step would be, as I mentioned, create that shipyard file. So you create a project in Keptn. So Keptn also has a command line interface that allows you to interact with it. And in this example, we use the sock shop example from Weaveworks. You might be familiar with it if you play around a little bit with Kubernetes. And then you specify the shipyard YAML file. So this is this file. And then you can specify also Git access information, so a username, password, and the repository. And then it will store that in the repository for you. And you can see, so we have this file. It's a shipyard file. You give it a name, and then you have a stage. So it's a bit truncated, but at least we see the first one, which is dev. And every stage has different sequences. So for example, for delivery, there's a task deployment, which is a direct deployment, as opposed to blue-green, for example, as I just mentioned. And then it can run some tests. So that's the next task. It runs functional tests and does an evaluation. And once that evaluation is done, it will release it to the next stage. And then after you've defined a project, you need to onboard services. And so I mentioned we use that sock shop example. So it's a carts service and a carts DB service. So quite a small and simple example, but it serves the purpose for today. So you onboard that service in the sock shop project. And here we specify the Helm chart because we're going to deploy it with a Helm. And then in order to add tests, tests will be run using JMeter. So we add some resources. So you can see another command that says add resources to the project. And when you use the JMeter service in Keptn, it will look into that JMeter folder for JMX files. So JMeter projects, and then run those in the corresponding stage. And then once that's set up, the next step would be to actually trigger a new deployment. So again, a new event, which is, okay, there's a new artifact available for this project for the cart service. And then you can specify the image. In that case, we'll get it from Docker. So you see it's actually a Keptn example, the carts, and then pass in the version. And it will start a deployment to dev, run the tests, evaluate those tests, then go forward to staging, if it's green, of course. Run the performance tests, again, do an evaluation, and then move that forward to staging and production. And this is how it can look like. And in this example, actually, we see it passed. It was green, it went through. And this is because we haven't yet defined the SLIs and SLOs that we want to use. But let me just quickly switch over to the UI. If I find my right browser window, there we go. So this is the project I just explained. So I already created it because it would have taken too much time to do it live. But we see this created this sock shop problem. I have a GitHub repository where the files are stored. And looking at the sock shop project, we see the different stages, so development, staging, and production. And we have the two services, carts and cartsDB. And for every service, you can see which version is deployed in which environment. So 0.12.2 is in development and staging, and 0.12.1 is in production. And this is basically kind of the basic setup that we have. And looking at it in GitHub, these are the files that were stored. So we have the shipyard file, as I mentioned before. So the one that I specified when I created the project is here. So you can see the different stages, development, staging, and production. And then it will create a branch for each stage that you have. So if you look at the development stage, there's the two services that we onboarded, carts and cartsDB. And in the cards, we see the Helm chart, so that tells it how to deploy it. And we have that JMeter folder that I mentioned before, where we have the basic check that does the functional test. And switching over to, for example, staging, the structures were similar, but you have another test for JMeter, which is called load. And you see it's just a regular JMeter test plan, as you can export very easily from JMeter itself. All right, let me switch back to my slides. So now we have that basic setup, but of course, for now, there's no SLIs and SLOs defined. But before we do that, let's quickly have a look, maybe a recap. I'm not sure if everyone is familiar with the terms SLIs, SLOs, and SLAs, but they you can read more about them from the Google's SRE practice. That's where they become popular from. So basically, these are three different terms, right? You have service level indicators, SLIs, and I guess the best way to describe an SLI is just a metric, right? It's something that you measure, like the error rate of the logins or the error rate on a specific page. So you measure that gives you your service level indicator. Once you have an SLI defined, now the next step is you need to define, okay, what is the good value of that? What's the kind of acceptable error rate? And this becomes your objective. So saying we have our login that has a specific error rate, and we could define, okay, let's aim for an error rate not higher than 2% over a 30-day period. So that would be your service level objective. So it's based on the SLI, but it gives it a target or an objective, as the term defines. And then the last one, which is probably the most popular because we see that mentioned in a lot of places, is the service level agreement. And basically, this is more the contractual agreement. For example, if you sign up for a SaaS solution, you would see something in their SLAs that says we have an uptime of 99.9%, for example. So that would be kind of a business agreement. And then if you want to read a bit more or listen a bit more, there's actually a good video that I can recommend, which is called SLIs, SLOs, SLAs, Oh My. So that's a video from Google that explains these terms actually quite nicely. I think it's a couple of minutes long, so it's not going to take you 2.5 hours. It's maybe 10 minutes or something. All right, so now that we looked at what SLIs and SLOs are, and of course in the pipeline you're only going to use SLIs and SLOs because, as I mentioned, the SLAs, that's probably more something for the lawyers if things turn bad, but what you measure and what you work against are the SLIs and SLOs. And these are defined in two different files. So there's the SLI definition. Again, this is all configured in YAML. So we have different indicators. We have the throughput, error rate, response time for different percentages, 50, 90, 95. This is just an example that I use here. You can see then there's a metric that it will fetch. So this is kind of the metric how it is called in Dynatrace. I'll do the example today in Dynatrace, but if this was done with Prometheus, you would have PromQL here that defines how to fetch those metrics from Prometheus. And then once you have the SLIs defined, you need to define your objectives. So as you can see, the objective is based on an SLI. So we take the response time 95. You can define a name. You can define it as a key SLI or not. So if it's a key SLI, it always has to pass. Otherwise, it will just take part of the whole evaluation. And then you define a pass and a warning for this specific SLI. And the nice thing here is we can use absolute or relative values. And this comes in quite handy because you're not always going to know what you expect in terms of absolute values. What's the typical response time for your login? You might not know. But one thing that for sure you know is when you develop a new version of your application, of your service or whatever, what you want is that it's not slower or at least not significantly slower than the previous build, right? Otherwise, somebody's not going to be happy. And then you can define, for example, this means it should not be more than 10% slower than the previous build that we had, and the absolute value shouldn't be slower than 600 milliseconds. So that would be the pass criteria. And then a second criteria for the warning would be that if it's below 800 milliseconds, so meaning between 600 and 800 would be a warning, and everything above would be a fail. And then this gives you a score. So this is quite simple because you only have one objective, but you can imagine you might have quite a lot of them, and in the total it will create a score. And then for 90% of the criteria must be matched to have a pass, or 75% to have a warning. And then you can define what happens in a pass. Typically when it's a pass, so it's green, it will move to the next stage. Typically when it's a warning, it will require a manual approval for the next stage. So that's how you would do it in Keptn. So you start an evaluation, then you say, okay, I'll evaluate my service using those configured files. And then you can query so it will query the SLIs basically using the provider. So you can have different providers, whether it's Dynatrace, Prometheus, or any other tool. And then it will fetch the values. And a typical one that I mentioned in my example would be response times, right? That's what a lot of people like to measure the kind of the quality of what you deliver, but it could also be something a bit more far-fetched, like the number of database calls. So if suddenly you go from 5 database calls on a request to 20, there might be an issue. So that's kind of basically every metric that you can get out of your monitoring environment could be used. And then it will give a score. So from 0 to 1, you can see, for example, 0.5, 1.0, or 0. And then this gives you a total score. So this one would be, for example, 7 out of 8, gives you 87.5%, might be a pass. And then if you only have 50%, this would be a fail. And just to complete this, so what we have done now so far is adding a monitoring environment that will provide this this value for you. So here's the example on how you would add, for example, the Dynatrace service for Keptn. And then the first thing is you define a secret that tells it how to connect to your environment using an API key and the endpoint of your environment, and then apply basically a custom resource that will deploy this service in the Keptn environment. And then you can use that to retrieve the SLIs. And then the next step would just be to configure that for the specific project. So again, in Keptn, you can have different projects, so you need to define which project uses which provider, for example, for the monitoring. And once that's set up, it will use those files to do the evaluation. And I think as a next step, I'll switch back to the demo environment. And what I'll do is, if I can find my shell, I'll just trigger a new deployment. Let me just go back. So I'll just trigger a delivery. So this is similar to what I've shown before. Say Keptn trigger delivery for my project. Now I'll deploy the card service from this Docker image in the version 12.1. And I'll do something else at the same time. I will have a look at my pods. So for example, if you look at my pods, I have a namespace for every environment. So for example, the stock shop staging, and I'll do this as a watch so we can see what happens. And I'll also let this run in the background because this can take a while. And of course, my session expired. So just give me 1 second to refresh my session. So this uses AWS. It's an EKS cluster that I've set up just for this example. This is why I need to have this remote cluster, and it expires every 60 seconds. Sorry, every 60 minutes. So I have to refresh that real quick. Be able to access that cluster, but I mean, it doesn't matter. The build has been triggered, so at least that's running, and it will take roughly, I think, 10 minutes to run through. So we'll see if we have enough time to see the results. Right now, I should be able to do a watch. And now we see, so there's in my staging environment, there are 2 pods that are running. So we haven't reached the staging environment in the pipeline yet. But for now, this is the conversion that's running. We have 1 database and 1 primary version, and we'll see in a bit when it goes to the staging environment that it will actually create a different than the primary. So that's due to the blue-green deployment. If I go back to the bridge, so now I can have a look at my sequences, and we see the different deliveries that have been triggered. This is the one I just triggered. We can see it's running. It started a minute ago. So we're in the dev stage. It did the deployment, it ran the tests, and now it does the evaluation. And then it'll fetch that and move along. So while it does that, I'll just show maybe an older release. So one I did earlier today. But now we see this went through. So we see development, staging, and production. And in development, the delivery, the deployment, run the tests, the evaluation, it was all good. Moved it forward to the staging, where it did the deployment, ran the test. We see the evaluation was also good, and then it moved it to production. Then in production, of course, we're not going to run any tests in productions. We have the users doing that for us. So it will just do the deployment. And then for every evaluation, I can look at the history, and this is where it becomes interesting. So you can see which builds were good, which one failed. And so we see this is the latest one I did earlier today. So soon there'll hopefully be a new one that's hopefully green. But earlier today also I did a new release, which actually did not pass. So we see it's red. So at the top, we see the overall score, and then we see the different objectives. For now, there's only 1 defined. So these would always have the same color, but here we see the response time 95, which we said needs to be below 800 for a warning, below 600 for a pass, and also below 10%, which actually is also listed down here where we see the details. So it was measured at 1000 milliseconds. So of course it did not pass because the pass criteria is way lower, and also the warning criteria is way lower, and we get a score of 0. And of course now the interesting thing is also to have a look, okay, what happened with that build. So I compare it to another one. This has quite a low response time of lower than 300 milliseconds. So this is something we can have a look at, and I'll just switch over to my Dynatrace environment. So the environment that monitors the service and is used as the SLI provider. So that's where we have the measurements from. And now, of course, this allows me also to go in here and have a look at what happened actually on that service. Why did it go so slow? Because it's nice to know that it failed and that we stopped the delivery, but now we need to figure out what happened and fix it. And then I can have a look at the service. So it's this items controller that's part of this card service. And if I look at the requests, I can see, of course, this is only in my test EKS cluster, so there's not many requests. We can actually see there's only requests whenever I launch a build. For example, one that I did this morning, which had a median response time of around 100 milliseconds. Then I had one a bit later in the morning that had response time around 1 second. And then again, another one that had also around 100 milliseconds. So this is the one that failed. And of course, now the interesting part is going to see, okay, what happened. And I can have a look at the transactions. And as you can see, every transaction has a response time around 1 second. And if I take a look at what happened, so we see there's a request coming into the items controller, which adds something to the cart, which hits the MongoDB a number of times. But we can see the MongoDB requests are really quite fast. So it's really in that service that it takes time. And looking at it, we see the time breakdown. I can see add cart took 1 second, but everything below it is quite short, right? So this is the MongoDB calls. And looking at the method hotspots, I can actually see, okay, there's been thread.sleep. So obviously we built that kind of as as an example for Keptn to show the pipeline. So it does a thread.sleep for 1 second, and then it will of course slow everything down and make the build or the pipeline fail. So I'm just going to go back to Keptn and look at where we are. Now we are in staging, and we can actually see it's spun up a number of new pods, and it will run that the tests on these pods, and then the primary one is still running, so it doesn't disrupt it. And once these are done, it'll tear them down and remove them, and then deploy the version to the new primary one, basically. All right, let me go back to my slides. Just need to be course of time here. I think I'm closing in to the 45 minutes that I had. So just want to kind of highlight another aspect. So I showed how we build this pipeline where we have this SLO and SLI based delivery pipeline, which does the builds, deploys them, and then has like the quality gates. But if another use case that I mentioned before is the auto remediation. I think this one, and there's different more use cases, but I really like this one. I think it's quite interesting what we can do with auto remediation, because that means when you monitor your production environment, you might get alerts. So an alert might be triggered by your monitoring environment, kind of a performance issue or error rates go up. And this can be integrated to Keptn as well. And then you define what you would like to do in as a remediation step. So for example, if the response time go down or go up, I guess I should say, become worse, you can define the step. And then you might have different remediations that you could do. One would be to scale a replica set by 1. So this is quite simple, right? You see performance issue, we add another node, and then hopefully that works better. Or the next one, which I think is a bit more interesting, because this one you probably could do also using a cloud provider which does this automatically, or a smart solution even on-prem that does this automatically. But this one, for example, is if you have feature toggles. So let's say you have a new feature, you bring it out, you have a feature toggle that allows you to enable or disable it. You realize that there's a performance issue, you might decide to toggle the feature flag automatically in order to remediate the performance problem. And then what will happen is, so here it will look at it detects the problem, will look at the first remediation action, which is that scaling. So it will scale it by 1, do an evaluation in Keptn. If it's not solved, it will move to the next remediation step, which is the toggle feature, and then see if that is solves the problem. And if not, it'll probably wake somebody up in the middle of the night that has to go in and fix the issue. And again, this is kind of what we did a little bit also in the example I showed today. So this automated approval that we can use to actually deploy to different stages and do this automatically, as opposed to have somebody to go in and approve manually. So when we run some scripts using JMeter and then get the metrics back, and then use that as kind of approval steps based on those SLIs. So as I've shown in my example, different metrics, but of course it could be basically anything that you measure. Right here, for example, we will look at the garbage collection, or you could look at the host it's running on, if there's kind of a CPU that goes up, things like that, and then decide if this should go forward to the next stage and have this nice kind of build evaluation based on that score that will create on the criteria that will be defined. All right, to quickly wrap up what we've done or what we looked at today. So this is kind of the same slide as before. So we were looking at the SLO-based quality gates. I showed you how this works with the different configuration files that we have, connecting the services. So we used was, of course, JMeter, Helm, Kubernetes, and Dynatrace for monitoring. And then using Keptn in between, basically as the glue, as the control plane that connects the different services. And then, as I said, so kind of conceptually how it looks like, it's a control plane, and it uses a number of different services. So it's very pluggable. You can add new services quite easily. There's a number of extensions that, of course, exist, or services that exist for different solutions. As I mentioned, it takes a GitOps approach as integration to GitHub. I think it's a general integration actually to Git, so it doesn't matter which one you use. You can use the container registry, for example, to pull images. Integration to different test automation. So JMeter is the one I use today, but you could use Neoload or Litmus Cows that are also available. Integrations to tools like Slack, which can be nice because then you can integrate that into a Slack channel, for example. Of course, use the tool you want. So today there's actually solutions for, or a service for Prometheus and Dynatrace, but again, this could be extended to any other monitoring environment. Maybe use some dashboarding. You could also generate dashboards automatically based on the outcomes of the delivery pipeline. And yeah, as I mentioned, a number of ready-made services exist. Argo CD, Helm. There's one for Jenkins, Azure Pipelines, and the different test frameworks. We have for observability, and then integration. I think there's also team integration that I did not mention before. And of course, it's open source, so contributions are always welcome. So this, I assume, will grow over time. And then just kind of a quick also teaser that I want to do, because this I saw this just this week. It's a new article, and it's a story about an Austrian bank, Raiffeisen, who uses Keptn, and it's actually quite nice. It's not a very long read. It says 5 minutes, so there's a link to Medium, where you can see how this is used, for example, as a customer. All right, that was it from me today. I don't know if there's, let me see if I can actually find the chat, if I can see if there's questions coming in.
Thank you very much, Robin. So I'm looking at the YouTube channel. So far there is no more question. Me, I would be keen to learn a little bit more about what you said about Raiffeisen. You know, like if you can share, of course, what they do, how they do it in a couple minutes, not without going in too many details, but it's interesting to know like a concrete case.
Yeah, sure. Let me actually,
if you can.
if I can click, nah, just need to see if I can click on my link, or maybe I have to open it this way. I can actually just quickly pull up the article. Of course, I'm not going to read the article for you, but it's just to, it shows actually quite nicely. So they have different tools that they use. So they use JMeter for the tests, and there's a strong integration with Jenkins. And there's also a tool called Digital AI release, I think, but actually I never heard of that before. So that was actually new to me. And that's how they build their pipeline, and you can see it. It's quite nicely explained in the article. So there's different steps involved, and they have where I showed you, for example, how Keptn shows the score. They have that integrated into Jenkins. So they use Jenkins kind of as their main tool to trigger deployments or to trigger load tests, and they use that integration with Keptn to get the results back and see kind of was this a good release, is it green, yellow, or not. And then they get these results. And I think the other thing I wanted to mention, which I thought was quite cool, is they also have integration to Jira. No, not Jira. What's the other one? Confluence. Yep. So they actually update kind of a Confluence page. So they have that also documented what happened during kind of for every build, right? It has this timeline, but it will also go and update the wiki that they have internally and that they use. And that's that's kind of, I guess, in a very quick overview what they do. But yeah, I recommend you to, I don't know, maybe I can actually, I'll just post it. Can I post something? I need to sign in. I'll post it later in the YouTube channel so people can follow the link. But as I mentioned, yeah, it's a short read, but it's quite nice. I think at the end also there's a little words about they had some ideas on how to improve and also collaborated on Keptn
Super.
itself to bring new features.
Awesome. Thank you very much.
Yeah, thanks for the question.
Great. I had some questions as well.
Yeah.
Well, I'm guessing that's interesting. Would you say that the part that monitors the application would be a full replacement for Alert Manager, for example?
I didn't capture that. The last part would be replacement for
Alert Manager. When you
yeah.
plug Alert Manager to Prometheus, so it replaces it entirely with more flexibility.
Yeah, exactly. So that's really kind of the aim, that it's kind of plug and play in a sense that we really have these integration points that it's based on events. So for example, you can trigger an alert. It doesn't matter where it comes from for Keptn, right? So it's triggered whether it's, as you mentioned, Prometheus or whether it's Dynatrace or any other solution. That's the two ones that exist today, but hopefully somebody will create new solutions in the future.
And I was wondering about something because you talked about Argo CD integration, and I can imagine how Argo CD can integrate as far as deploying the software. So Keptn could automate the deployment of software using Argo CD, but can it also integrate for remediation? Because, for example, the changing the replica sets is typically something that could conflict with the Argo CD code. And so would it be able to interact with Argo CD to do it in a way that would be GitOps approach?
Yeah, exactly. So I'm personally not familiar with Argo CD, but the idea would be, I mean, you define your remediation steps, and those could go to Argo CD as well. Again, Keptn doesn't have an opinion on how you do things. Also, my example, for example, I used Helm to deploy, which is nice if you are in a Kubernetes environment. But if you're in, like, let's say, a more traditional stack, you're not going to deploy it through Helm. So in the end, it just says, okay, deploy something, and then it needs to know, of course, where to send that information to. But then with, for example, the integration to Argo CD, you could say, okay, Argo CD, deploy me this version of that artifact, and it could pick it up maybe in Artifactory or whatever you have it, and place it into an environment. And the same would go for remediation. So that means you could use Argo CD or anything else. I mean, there's no kind of big remediation functionality built into Keptn. A simple one, if you're again in Kubernetes, would be just increase the replica set. But as you mentioned, and I think it's a good point, you of course need to make sure that you're not going to increase the replica set, and then another tool comes and says, whoa, no, that's not how I expect the environment to be, and fixes it back to the other replica set. So that's really one of the kind of the, if I maybe I'll just switch back to, I can find my slides again. This idea of having this kind of control plane and have something simple and not dependent on the specific tools, but really helping the integration of tools, because there's so many different tools, and I guess we just touched on the major ones, but even smaller tools around that are used.
And so these tools, you write plugins, there's a specific language, or it's Go executable, or
so everything runs in Kubernetes, right? So Keptn runs inside of
containers,
Kubernetes.
I guess.
So I guess Keptn itself is Go. But in the end, I mean, you can write in what you want as long as it uses the API. Actually, it didn't show that part, but of course it has an API, and of course it actually uses cloud events, so a standard way of sending and receiving events, and you would have to plug into that.
Okay.
Actually, that just reminds me, we can actually have a look at what happened here in the meantime. I almost forgot about this guy. So this is the deployment I triggered before. And now you can see, so it started a new pod. It run the tests. It's a little bit big, so I'll just, they run for roughly 10 minutes, and then they were good. So it deployed a new primary. Terminated the other primary, and terminated also the other pods it used for the tests. And then you have the new environment. And I'll do this quick because I know I'm running out of time. And now you would see, so we have the new version again. We're back to one DB and one primary. The DB should still be the same, right? 598, but the primary, of course, it changed to the new version. You can see it's different.
Great.
All right, I think it's time for a break. Is that where we are at, Jay?
Yes, thank you very much, Robin. So now I will just share as well the screen. So thank you very much. So that was Robin explaining to us about Dynatrace and Keptn. So we will have a 5-minute break where please download the Slido, and because like this, this cloud native meetup is also your cloud native meetup. So we are always keen to know what are you interested in, or if you want to present a topic. So if you can share it with us here, and like this, we'll be able to see it after the 5-minute break. And now it's time for you to rest 5 minutes, have a drink, and see you in 5 minutes. Rebonjour. Thank you very much for joining us back. So let's see. So we didn't have that many topics. So apparently not Kubeflow. I think that was a Kubeflow that someone was mentioning. So we will keep this line open as well during the second presentation from Mohamed. And like this, if you have ideas of what you want to share or what you want to see as well, we are always keen on trying to find the new speakers that interest the crowd. So thank you very much. Now we'll leave the floor to Mohamed, and he will talk about the cloud native patterns and anti-patterns. And so Mohamed, whenever, from what I understood, to apologize, there is a glitch with the video of Mohamed, so we will hear, but the content is the most important one. So Mohamed, the floor is yours. Thank you.
Thank you, Thierry. Can you hear me?
Perfectly well.
Cool. Thank you, Thierry, for the introduction. So, hello everyone. My name is Mohamed Amine Dridi. I'm a DevOps engineer at Camptocamp, and I'll be talking today about cloud native patterns and any patterns. And I will be taking a different approach. I mean, I will tackle this subject from a different perspective to try to complement the previous presentations that were given as part of this Meetup series that were more focused on the tooling and on the, let's say, the operational aspects of cloud native. And I will try to tackle it more from a software engineering, a developer perspective. And this is an attempt to go back to the basics and try to figure out what are the core issues that we are dealing with here. So I will start by asking a very simple question: what is cloud native? And I'm pretty sure that if you take any random number of people, and ask them this question, you will probably get one of these answers. So some of them will tell you that cloud native, it's about Kubernetes. As long as you have a Kubernetes cluster and your application is running on it, then you are cloud native. Others will focus on the architectural side of things, and they will probably talk about microservices. Some will focus more on the technical side of things, and you will hear answers like cloud native, it's containers, and the whole thing started with Docker, etc. On the fancier side, you will get answers like cloud native it's about service meshes, and which is a new concept, which is an exciting new concept that decouples the connectivity side from the business logic side and application, and allows you to enhance the service discovery within your application and things like this. And the answer that you are probably going to get the most is cloud native application. Cloud native application means that it's an application that is born in the cloud, which is not very instructive as an answer, but it's probably the closest to the reality. And I will explain this in a few minutes. So what is my view about cloud native? I tend to have a view about cloud native that is close to let's say, Steve Jobs' view for personal computers 35 years ago. I'm not comparing myself to him here, but I found the analogy very interesting, When he was asked about his vision and his view about the personal computers, he said that these are a new medium for software, the same way that books used to be a medium for their own kind of software. And he made the following statement, which I found really interesting, is that every time there is a new medium, people tend to fall back into old habits from old media. He gave a really good example to explain this with the radio and the TV, and later the laser discs. So when the TV appeared in the US back like maybe some 90 or 80 years ago, the first programs were a camera pointed at the radio show. So this is, I mean, an example of how people are falling back to old habits. And it took around 20 to 30 years for TV to come in as an industry on its own. And the same thing happened decades later when the laser discs appeared. So people started printing movies on them. So again, falling back into the old habits. So I'm taking the same example and applying it here to the cloud adoption. And by the way, in a sense, you can even see the cloud as a medium for some kind of software. What happened is that when the cloud first appeared, people just saw it as a virtualization layer on top of general purpose compute and storage nodes, which was the wrong way to see it. They didn't see it as a new ecosystem with new possibilities and new characteristics. And they didn't really think ecosystematically about how to approach the cloud and how to adopt the cloud and move their workloads to the cloud. So the same assumption happens to every paradigm shift and the cloud in particular. So what I'm trying to do in this presentation is to go a little bit back and see what are the major, let's say, patterns that characterize the cloud native approach. And for me, this is not an exhaustive list, but I somehow managed to classify, let's say, these patterns in 4 categories. First, you have the microservices architecture, which is a crucial and the critical part of cloud native application. Because if this goes wrong, the whole thing falls apart. And then later, I will talk a little bit about platforms and the platform as a service concept, which is replacing the traditional infrastructure as a service concept that was adopted earlier. I'll talk about stateless processing, and I'll finish with automation by design. So let me start with microservices. There are many definitions about what microservices are. I mean, this kind of architectures existed for several years now, if not decades. And among the many definitions of microservices, I found that this one that was given by an ex-Netflix engineer, the most concise and complete. And he says that microservices are a service-oriented architecture composed of loosely coupled elements that have bounded contexts. So we have 3 keywords here, and from this definition, we can already understand that microservices architecture is a derivative of another architecture, which is the SOA, service-oriented architecture, that has been around for a few decades. And it's focused on a specific unit, which is the service. And the service, according to this architecture, is a self-contained unit of software functionality that is designed to perform a specific task. What is the advantage of approaching the architecture this way is that you get, the main advantage for me is that you get this abstraction, because now we are just consuming the service, a piece of functionality, and you are no longer caring about the internal, let's say, implementation and the logic behind it. The second keyword is loosely coupled. You need to have this loose coupling within your architecture. And this means that every component or set of components that compose your application need to have the least possible amount of interactions with others. And you will see the advantages of having this, let's say, implementing things this way a few minutes later. And the third characteristic of microservices is that components tend to have a bounded context, which means that within a component set, you have a certain consistency. And so all the data and functionalities refer to a specific logic and a specific area. Okay, so probably the best way to explain the benefits of microservices is comparing them with what exists today and what existed before, which are the monolithic applications. And of course, if microservices were done in the right way. So with monoliths that are deployed today, we have too many issues. Probably we have a couple of, not a lot, but a couple of, let's say, advantages like performance, maybe, since components are communicating using memory and processing and communicating directly and not over the network, but the disadvantages are more relevant here. Within a monolithic application, you get all the dependency issues. Since you are using shared libraries, you are tied with a single language, usually, because you have the whole code base is made of, is written using one language, and you don't have the flexibility of choosing the right paradigm or language for a specific part of your software. The more it grows, the more the code base becomes hard to understand and to modify. Scaling, you cannot do fine-grained scaling, since if you want some part of your application to grow, to scale in, let's say some part of your application, or scale out, you're obliged in this case to scale the whole thing together. And what we saw also is that the deployments are usually slow and hard to stabilize once they are in place. On the other hand, microservices, when you implement them the right way, offer you quite a few advantages compared to this. Also with their own disadvantages, like the performance decrease that you get since you are communicating over the network and not directly. So the main advantage is, one of the main advantages is that you can use the right language and the right paradigm for each part of your application. Another one is that you are able to iterate faster, since it's easier to read the code base and to add modifications to it. If something wrong happens in your system, the failure blast radius is limited. For scaling, you no longer have to scale the whole thing to get some part perform better. Now you can just focus on a specific part of your application and scale it horizontally, for example. You're able to compose and reuse different components of your applications. And this kind of architecture allows your team to work independently from each other, since you have this context. You can bound your different contexts. So this is a comparison between both, but things can go wrong, and there is a major anti-pattern with microservices that most people fall into, which is the network monolith. If you do not implement it right, you can have a situation when you have the worst of both worlds, which means that you get all the overhead, all the complexity from microservices, and you get stuck with the rigidity and lack of flexibility of monoliths. Let's say there are some common cases where you fall into this kind of issues of any pattern. First, if you start implementing your microservices based on data model, okay, if you just take your database, look at the tables, you have different tables, and then you implement microservices related to each table. Like, for example, here I have a user table, orders table, and then I start building components around this data. This way, you can end up with pretty nasty architecture, and then I will show you later. And another mistake that people tend to do when they are approaching this microservice, trying to implement their application following the microservice architecture, is implementing technical microservices, which means that they decompose their monolith, for example, into some technical parts like event management or data aggregation, etc. And they try to create microservices around them. And this way, it's a wrong way to do things. And this is why, because probably you will end up with something like this. This is an illustration, let's say, of the microservice architecture that Uber used to have before. And as you can see here, it's really hard to understand, I mean, to get a grasp at the dependencies between the microservices. Something goes wrong, it's really, you don't have enough visibility into what's happening. You need, for instance, to go through different microservices to be able to understand what happened. And it's, there is no, let's say, there is no coherence, there is no limit to what an outage can do to your system. And of course, this also implies a lack of clear lines of service ownership, since everything is talking to everything. So there is no boundaries between your teams, and you don't really know who owns the specific service. So the question is, for me, how to solve, when I'm trying to think of how to solve this, is there a systematic way today to approach microservices? Is there a set of design rules, a systematic way to design a real, true, resilient microservice architecture? And fortunately, there is, and it's very recent, and I came across this article by Uber recently, and they took a very interesting approach into implementing their microservice architecture. I mean, it was mainly repairing the old microservice architecture, but based on new principles and a new approach, which they call the domain-oriented microservice architecture. And this is, let's say, this is inspired from older design rules, which is domain-driven design, but applying it to the microservice architecture is quite interesting. And let's say the main insight of this is that, of this approach, is that they took principles that used to be applied to writing software, for example, the object-oriented programming principles, and they applied it to the architecture. And they saw that the microservice architecture is just a large distributed program on top of which you can apply the same principles, and it can evolve in the same way as a piece of software. And they came up with 4 principles for this. They created this structure, clean way to design this architecture. They come up with 4 principles, which are the following. I'll explain a little bit further in details in the next parts. First, domains, layer, extensions, and gateways. And here I put here the URL for this article that I encourage everyone to have a look at. So the first, let's say, principle and their design rule are domains. These domains are collections of one or more microservices that have a certain coherency, that are related to a specific logic in a specific area. And as you can see in this very simplified figure, I mean, when you implement domains, you create some, they are not explicit, but you create some implicit boundaries between these domains. And there is no limit to how big or small a domain could be, by the way. A few examples here. So based on the Uber experience, so they divided their domains in different parts. They had, for example, here map search services, some map search services, some fare services, and matching services. And already from the logic, from the name, you can understand that there is some there is some separation between the functionalities that are implemented in each domain, because in a map search, we'll have some map-related functionalities. For example, for matching, you'll probably get some more of a maybe AI-based tool that help matching drivers to customers. And for fare, you will have more of a payment logic behind. So you see that there is a separation between them. And the thing is, to focus on the logical consistency within a single domain. And these domains do not really necessarily have to follow the organization. And it's the opposite, which is true. The organization should follow the domain, let's say, separation. Okay. The second principle is are the layers. And here we are asking the question, what service can call what other services? And this is a way thinking that makes you able, let's say, to understand the failure blast radius within your architecture and the product specificity across the dependency. And I'll explain a little bit further. So as you can see on the figure on the right, so the more you go upwards, moving upwards, layer tend to impact fewer services. This is because layers only depends on layers under them. And I'll explain later the relation between the domains and the layers here, which is a little bit tricky. So if I give this example here, so you can imagine the top layer as a very customer-specific service, and the bottom layer, for example, as a very, let's say, generic functionality, such as, for example, account management or something like this. And moving upward, the failure blast radius becomes smaller, since it only affects this limited number of functionalities. The relation here between the layers and the domains is that there is no boundaries. I mean, it's not necessary to have a whole domain part of a specific layer. You can have different components that are part of different layers within a single domain, the same way that you can have different sets of components part of a layer inside the same domain. Yeah, so this is so just to say that you need to separate this layer concept from the domain concept and not match them, and think, for example, that the layer should always have should relate always to a single domain. The third principle is the principle of gateways, which facilitates, let's say, which limits the number of dependencies within your architecture. And the main point here is to create single entry points for each domain, or another way to say, each collection of underlying services. And this is practically the same idea of API gateways. So what you get from here is that upstream consumers are do now need to call only a single service, and are not really dependent on a big number of on a higher number of services, which can make things like migrations, for example, or failure management harder. Okay, so the main advantage, of course, as I said, is the dependency graph reduction. You get less dependencies and an improved discoverability within your architecture, service discoverability. And the last concept within this domain-oriented microservice architecture, which was a little bit hard for me to wrap my head around when I was reading the article, and I tried to simplify it here in this figure, is using extensions to be able to maintain these boundaries between the different domains. And I'll explain this using the following example. So when you want to add functionality to a service, you don't want to change its actual implementation. So when using extensions, you are able to do this. And there is a pretty good example that was given in the article by Oberg. For example, if you need to implement a new, let's say, service or functionality, which is go online, for example, that needs to make a couple of checks. So for example, some safety checks and some compliance checks. One way to do it is, as you can see on the left, you can go to that service and implement within that service the logic, for example, for safety and the logic for compliance. But here, as you can see, you crossed the boundaries between the domains, and you have people working on different domains now interviewing, and you have a lot of communication between the different domains to be able to implement this, and you no longer have this separation. So how extensions solve this issue? So now you just, instead of implementing this within the Go Online, you add an extension to your domain that is aware, let's say, of the Go Online functionality, okay? And this is done using interfaces, okay? So you implement this, you define clear interfaces of how your new functionality or that you are extending your domain with needs to follow. For example, in terms of input and output, you can, if you take the example of the safety check, so you can just take from the domain some safety checks, implement them within the interface, and output a Boolean when you say that the user, whether the user can go online or not. The same thing, you can do it, for example, with compliance. And later you have your original Go Online service asking for the output of these extensions. So getting these outputs as a set of yes or no, let's say, answers, iterates on this output, and then decides whether the, let's say, driver or customer has the right to go online. So extensions here, once again, use a principle that comes from the object-oriented programming paradigm, which is interfaces. So you kind of follow the polymorphism, let's say, principle here in implementing these extensions. And this way you can maintain these clear boundaries as long as you are respecting the interface declaration. So with these 4 principles, there are a few results that were communicated by Uber about their experience. They were able, using the extensions, for example, principle, to reduce the number of features, to reduce the new feature integration time by many orders of magnitude. They used to have 220 microservices, so they needed to manage the dependencies between all these, and now they classified them only in 70 domains, which gave them better visibility on what's happening in their system. So onboarding a new feature, so onboarding time for new features was reduced by a significant amount. Here it's 50%. The principle of gateways, so made these migrations easier, but also the discoverability within their architectures, and because there was a reduced number of dependencies. And the major, let's say, advantage is that following these principles, creating new lines of business became easier. They also give some recommendations on how you adopt, let's say, this kind of architecture, and how you move your existing systems to microservices, is to never do it in a one-off fashion. Never do it at once, but to do it in a progressive way. You start identifying your domains, and you start, like constructing these layers from the top. You define your customer-facing services, you move downward, and then later, once you have your different layers, you start, let's say, creating domains from the different microservices. And as you can see, this is more organized way to migrating to microservices than let's say, something that is focused on the technical aspects of your architecture, and where you can easily get lost and no longer have control of how your architecture is evolving. So what now, once you have your microservice architecture done, built in the right way, what do you need to have too? So, and here what the concept of platform as a service come in compared to YAS. So platform as a service provides you with a very important thing, which is an abstraction of resources, underlying resources. You can also have delegate the different parts of the management to the platform and let's say make your centralized management less complicated. And of course, within limited number of entry points, you have a huge complexity reduction. So among the platforms that there are several platforms that claim to be, let's say, cloud native, but among them, for me, there is only one, which is Kubernetes. I mean, it's a big statement that I'm going to say here, but I believe that things like Rancher, like OpenStack, for example, are mistakes along the way. Okay, so and they helped understanding what went wrong, and they helped develop. I mean, understanding now why we need Kubernetes as a platform. And why is that? Because Kubernetes has the necessary primitives for a true microservice deployment. It follows the declarative approach compared to an imperative approach, where you need to specify everything that your system needs to do, and it becomes impossible once your distributed system has a significant size. It has the necessary abstractions, for example, the node abstraction, the service abstraction, and it's extensible. And using Kubernetes, you are able to build more and more opinionated platforms on top of this path. Of course, there is a lot more, but here the main point is to show, let's say, or explain what is the right platform that you need to have in place to have a real and comprehensive microservice architecture. So another point, it's about stateless processing. And this is a very important point too, since you want to be able to scale in and scale out your components horizontally. And for that, you need your components to be stateless, which means that these components do not store any long-lasting state within them. They do not persist anything. Any transactional context is stored remotely. And even the interfaces that these components are implemented are stateless, for example, the REST API. So all the information that is needed to process a request needs to be within that request. And as I said, this allows you to scale your application horizontally compared to vertically, and it adds certain resiliency to your architecture, since if one of your components goes down, you have your load balancer here, so routing the traffic to another component. But there are a few things to watch out for, and probably the most dangerous one is the overhead that this kind of, let's say, that stateless processing induces, since now you are going back and forth to the database every time you have a request. I mean, to request the context, to request the session information and things like this. So you need to really be careful about the overhead that you are adding to the system, because it can really impact the performances of your overall application. And the final point here, let's say the final pattern when you are designing cloud native applications, is that you add some automation during the design. And the reason here, because you will soon, once you are deploying a microservice architecture, you will have a substantial number of microservices. So you kind of need some kind of orchestration, some kind of automation at multiple levels. For example, at the orchestration levels, so you do not scale or your components individually, but you need to have the automation within your orchestration that do it for you. For example, a few examples of automation at design phase. For example, the automation of IP assignment. You need to have your configuration shared in shared stores. Also, the discovery of different services within your architecture needs to be automated too. And of course, you need to eliminate any hard dependencies. So to summarize here, I want to say that if you want to claim that your application is cloud native, that your design is cloud native, ask yourself at least these 4 questions. Am I following the right approach to building microservices? Are my components stateless? Am I deploying, and we can safely say this today, am I deploying my, let's say, application, is the execution environment of my application Kubernetes, and do I have the necessary automation within my application? So if one of these things, if you're not, let's say, satisfying one of these conditions, then you need to rethink your architecture and you need to think the way you're doing things because it's not cloud native. So I'm a little ahead of time, which is good since it's a little bit late. So thank you for your attention. And if you have any questions, please let me know.
Thank you very much, Mohamed. So far, so I was monitoring the YouTube channel, so there is no question so far. I don't know if Robin or Raphael have one question or not regarding the presentation. And
yeah, maybe I have a quick question. So thanks, Mohamed, for the presentation. I think that was quite interesting. I really like that domain-oriented microservices architecture that you mentioned. So I didn't know that before, and I wanted to ask if you know if there's like adoption outside of Uber. Is that if other large corporations that also work with microservices, if they have used it? I don't know if you know something about that, or if you heard something about it.
I mean, there are a few. Apart from Uber, as you know, there are a few poster children, let's say, of the cloud native movement. So, for example, if you Netflix, or there are a few companies that are doing, I mean, that are adopting the microservice architecture, but are they doing it? I mean, here I'm gonna answer just for the case of Uber. So I believe that they present at least the right way to do it, because you can have microservice architecture. I'm pretty sure that there is a bunch of companies, probably a lot of them, that claim that they have a good microservice architecture, but which is not the case, since we hear a lot of companies that fall into this pattern and have what we call here the Death Star, where at some point they end up with the distributed monolith, and they end up with something where they cannot figure what are the dependencies, and they don't have any visibility. So apart from Uber, I don't know about any other company that adopted this concept. Actually, it was developed within Uber and published the last year, in Q2 the last year. So it's pretty new, and they are saying too that it's that they are still working on this architecture and still trying to perform it, and they are learning from the data that they are collecting about this architecture and their own experience. So to summarize the answer, microservices, yes. Domain-oriented microservices, I don't know if there is any other company that is doing it.
Okay, yeah, thanks for your reply. It's going to be interesting to see if this becomes kind of more of a general architecture that will be adopted by other large companies. But, and maybe a second question. I hope we have time. Do you know if Uber built some tooling around that would support that approach? I don't know if it's like frameworks or just tools that help them.
Probably, but they probably didn't publish it. But I also said that they will publish things as long as they have it. But the tooling, I suspect that they have specific things. I mean, they have things that they develop themselves to support these new concepts. But I don't think it's published yet. But if it gets published, of course, I'll let you know.
Okay, good. Yeah, that would be interesting.
Pretty sure that this is. I have a feeling that this is something that is going to become a standard, because the main point, once again, is that we are talking about microservices, but we still don't have a systematic way to build resilient microservices architecture. And this is why many companies now, and this is why many persons are reluctant to the microservice architecture and are a little bit, do not really want to do the migration from what they have right now to something that is more distributed, because there is no clear way, and the risk is high. The risk is that you invest a lot into building an architecture that ends up even worse than what you had before. So the only fact of having, let's say, structure, guidelines, clear way to do things, it's extremely important. And to have an experience from a company such as Uber, which is once again poster child of cloud native and the cloud, it's quite reassuring, let's say. And that's why I think there is something that is going to be standard, that is going to attract many people.
Okay, thanks. Yeah.
You're welcome.
Thank you very much. Thank you, Robin. Thank you, Mohamed, for all this time and the preparation and sharing your knowledge with us. So now we will go back to the end of this Cloud Native Romandie meetup. So if you have a few questions, don't hesitate. We are still reachable. You can join us either as well on the Meetup group or anywhere on YouTube. You can find us as well. And just to let you know, in the next events, so we are part of the Swiss Cloud Native Alliance with our colleagues from Puzzle and from Puzzle Bern and from Vision from Zurich. And so we will organize they're organizing the Cloud Native Meetup Bern for the Swiss Cloud Native Day, on Thursday, September 23rd. And regarding Cloud Native Romandie meetups, we will be happy to see you after the summer on October 7th, and then for the fourth one at the end of the year on November 25th. In the meantime, if you have any doubt, please let us know, because we would be happy to know what are you interested in. Like I mentioned a little bit earlier about the type of topics that you're interested in, what you like the most tonight, the speakers, what do you prefer? If you prefer on-site now, we are all getting vaccinated and being able to start to go back to a regular life. So to know if you prefer the virtual format comfortably from home, more flexible in terms of speakers and more flexible in terms of time and as well place, and or if you prefer to be on site and followed by the usual drink or time to meet with people, what meetups are for at the beginning. And we want to thank you, of course, so Robin another time from Dynatrace and Mohamed from Camptocamp for organizing and for setting this up and making all this long talks. Hopefully everybody had all the information that you wanted. And we want to thank as well the sponsored Camptocamp, Swiss Cloud Native and Meetup, and as well the CNCF. Thank you very much, everybody. You can find us back here. And if there is anything else, please let us know. We'd be happy to help you. Thank you. Have a good day.